So I've built a little circuit here which is partly on the route to building our stepper. So what we have here is just an SR latch. So there it's there, we've designed that previously. And we've connected 12 of them together. We've taken the 1st, 3rd, 5th, 7th, 9th, 11th, so all of the odd numbered ones. We've connected the resets to the inverse of the clock, so the inverse through this NOT gate, so that's connected to there, and then the 3rd one, the 5th, 7th, 9th and 11th. And we've connected all of the even ones, so 2, 4, 6, 8, 10 and 12. We've connected those to the clock. So we can see what's happening here. If we put a 1 in for the set bit, then whenever this set goes, the clock goes from low to high, so this, in this instance here, it's positive edge triggered, meaning from a low to a high. We can see here that when that's sitting at 0, we've got a 1 here, and we've got a 1 there, so this 1 is going to be passed through to the output here, and you can see that when we drop in, we have a 1 sitting on that output. So whenever we make this go high, then the one that's sitting at this output will then be passed to the output of this one, because the clock here has gone high, and that's the reset pin there has gone high, so our output there goes high. And again, whenever we go low, this value here will get passed on to this value, this point here. So there you can see that this value for our 1 has now got to this point. So it's got to this point here because the clock's gone low, but that point's gone high, and it's passed that 1 on to the output. So we can continue doing this, and we'll see that in effect it counts along. So that's that one come on, and that's the 3rd one, the 4th one, the 5th one, and the 6th one. So by pulsing this clock here, we turn these points on one at a time, so that's 1, 2, 3, 4, 5, 6. So we can use this as the basis of creating our stepper. So let's go and see how we can change this in order to make it do exactly what we're wanting it to do. So we've taken the same circuit and we've added a few extra gates. So you'll see here that the output here, we've added an extra NOT gate, and there's an OR gate here, and all the way along here there are AND gates along with the NOT gates. If I zoom out, you'll see those. So these are the OR gate and then the AND gates and the NOT gates in between. So let's have a look and see this working. So initially it has to be set, so in order to do that we have to pulse this. So this would have to go high and then low. So that's it been pulsed and it's been set. So in this condition here, we've passed a 0 to the output of this one here, which makes this point high, which gives us a high output here. Now whenever we clock this, now it's going to be positive edge triggered, so when it goes to a high, you see that this point here now is gone to high, and it's passed on the 1 that was here through onto this point here, and it's made this point high, and now this point has gone low. So these NOT gates allow this point here to go high then low, where previously all of them just remained high. So the same thing happens again whenever we pulse it on the positive edge. So when it goes low, it passes through onto this one, and when we go and pulse it again, it'll pass this one onto this section here and make this a 0. And you'll see it's done that there, and it's passed this 0 on to here and made this a value of 1. So we'll continue doing that all the way along until it gets to the very end. Now this is roughly what we're looking for, but it's slightly, we need to change it slightly. We actually need to make the whole stepper negative edge triggered. So let's go and we'll see why it is we need to do that. So what we have here is the output from the clock circuit. So you've seen this whenever we did the clock video. We have the original master clock coming in. We had the clock coming out, which is at half the rate, and then we generated the enable and the set. And we've seen here that if we start at this point here, whenever the enable goes high, so it will go high for one clock pulse, then the set will go high for a clock pulse, then the set will go low but the enable will remain high for a clock pulse, and then finally the enable will go low for the clock pulse and the set remains low for the clock pulse. So this is one enable set routine. So it takes 1, 2, 3, 4 of these clock pulses up here in order to go through this enable and set cycle. So if we ensure that at initialization of our CPU that the clock is in a 0 position, the enable is in a 1 position and the clock set is in a 0 position, then that means that we are actually starting at this point here. But we've made the stepper negative edge triggered, so that means that nothing will happen until the next negative edge comes in, and the next negative edge isn't until this point here. But that's perfect because that's exactly where we want to start the cycle, which is this point here. So if we ensure that this is the case, we get a 0, 1 and a 0, and we ensure that the stepper is negative edge triggered, then we will be starting at the correct point here. So this is positive edge triggered. What happens is whenever the clock goes from a low to a high, then it will step from one to the next. So we're sitting at a low at the moment. So when it goes to a high, that's the point at which it steps. So whenever we go low again, and then we go high, again it steps over there. So we don't want that to occur because that'll ensure that we don't start at the right point in the enable set cycle. So if we were to change this to make it negative edge triggered, all we need to do is move this NOT gate down to here. And now we've got the correct realization. So if we were to set that high, so that goes to set goes high and low, we set it up, but it won't trigger on the first cycle. It will only trigger whenever it goes from a high to a low. So there's no movement here at that point. The movement doesn't occur until the next cycle, which is on the negative edge. So from a high to a low, and then it triggers and moves on to the next point, and again from a high to a low, then it moves on to the next point. So with this realization here of the stepper, we just have to ensure that the inputs are in the right position, the initially are in the correct position. So as long as we start off in this condition here with the clock low, the enable high and the set low, then we know that we will start off the cycle in the correct condition because the stepper will start stepping on the negative edge, which is this point here. So that's us almost finished with the stepper. Only one more point to make and that will be us finished. So there's only one other thing to take care of here, and that's the fact that whenever we get to point 7 here, the counting stops. Really what we want to do is when it gets to 7 we want it to go back to 1 again and continue counting, and then back again and just continue counting for it to go on and on like that as long as the clock is pulsing. So let's have a look and see what's happening now. So we set it up initially, and it counts through 1, 2, 3, 4, 5, 6, and it gets to 7, and then it just stops. So it's quite easy to fix this. All we need to do is take a connection from the output here at point 7 and put it back to the set point here, and it means that we can move this pin here if we no longer need it. And if we run through the simulation again, you'll see now that it starts counting 3, 4, 5, 6, 7, and then back again, and you can see it's continually counting round. So that's us finished with the stepper, and we're getting it working exactly as we want it to. There's quite a lot involved in this video, and I have to admit that when I first tried to work this out, it took a few hours in order to get all of the timing correct for the CPU. But it was worthwhile because now we've got a timing which is very, very graded, so it means that we can see every single thing that happens within the enable set cycle. So that's all for this video. I'll get you in the next video. Goodbye.